Here's a look at page 3 of the review, starting with number 5. So the difficulty of this one is it's asking you to take the graph. Sorry, I got a little ahead of myself there. Let's back that up just a second. Second derivative, f double prime, is shown in the figure below. It's the far left one. And so what f double prime gives to us, its sign, positive or negative, tells us about the concavity of some function f. So my approach to this is I'm going to go find f of x, because I can take the f double prime of x graph. Its positive or negative regions will show me a graph. If I find f of x should be concave up and concave down in those regions. And so I'm going to do that kind of pairing. So what you're going to see here, see if you can catch this. I'm going to go play there a little bit. There's the first part. I've got some concave up and concave down chunks. So that is when f double prime is positive above the x-axis. I'm expecting f to be concave up, and when f double prime is below the x-axis, I'm expecting my f graph to be concave down. So of the two graphs, A or B, I'm going to go find one that for the same kind of x values, so if you look in the kind of around the y-axis on that f double prime graph, or that, I'll put a little highlighter right there on that one, that little negative there is something around the y-axis. That negative in f double prime means I should see a concave down graph for f of x. So I'm looking for an f of x graph that has a concave down region. And so if you look, B, right there, that's a concave down region centered in the same place that f double prime is negative. So concave down in f of x that I've highlighted on the B graph matches the negative sign of f double prime in the same x value region. So that's how I matched it up. I just looked at concavity, and then you can look at the positive concavity, maybe do a little different highlight color over here. If I do that like an orange in here, that little region in there, maybe I should highlight a little bit better here. Try it. You're hearing the sirens for a Saturday morning, so sorry if you're hearing that in the background. But I got my positives, and somewhere just to the right of the y-axis should be a concave up graph, and sure enough, right here in f of x, this is a concave up region that matches the x values in f double prime being positive. That's it. That's the matching I did. So I showed them over here. I matched them up with the negative signs in the concave down regions. I did it with some highlight in blue as well. And then I moved on. So number 6 is determine the intervals along the x-axis on which the derivative is positive. So you're going to ballpark it. And if you are just feeling, like you understand that I mean to ballpark it, you're welcome to put in 0.999 when you're talking about 1 or something silly, because you know that I'm asking you to approximate. But the idea is derivative is positive is an uphill region of the graph. There are 2 of them in the graph provided. Come up with some reasonable x values that describe that region. So I think 0 to 1 and 2 to 3 are great. If you put some decimal really close to those values, that would be just fine, but I'm going 0 to 1, 2 to 3, keeping it simple. And then the interval along the x-axis in which the second derivative is positive is a concavity issue. When is the graph concave up? And concave up is going to happen between any inflection points that are on there. So let's check it out. There's a concave up region there in that one, and then there's one more concave up region, and it's right over, let's see if I can get my highlighter working again, right here on this section. So you'd also write, I don't know, maybe 3.5 to 5, since it seems to end on there. So 3.5 to 5, 3.5 to 5. Oh, I just doubled it. I forgot the comma for the 5. There's another region where it's also concave up, which is when the second derivative is positive. Okay, and then the next page is page 3. I'll get to that with a different video pretty shortly.